This lesson covers the perimeter and area of 2D figures. You'll notice that this first slide here lays out exactly what we are going to be covering in this lesson. These are the shapes that you are going to see in this lesson, but of course there are many other shapes. We're not going to focus so much on polygons on this lesson so much as we are on 2D figures or basic shapes. The first thing we're going to do though is we're going to have to define what is perimeter and what is area. We say that the perimeter is the total measurement around a figure. And we calculate this usually by adding them all up. An area is not around a figure, but the space, and I'm right here, total space inside a figure. How much space is it taking up? All of these here use measurements, and we are always going to use units of measurement that are in the metric system in Canada. And we'll talk about this. We won't focus on conversion here, but when we talk about units of measurement, it's really important that when you are calculating the perimeter and the area, that your final answer should always have a unit. The special thing about area is that it's always units squared. So whatever the unit is, you put the same units squared. And the ones that we see in my class would be kilometers, hectometers, decameters, meters, decimeters, centimeters, and millimeters. And when we are dealing with units of measurement, in this case, they are the units of measurement for length. Area is a different way of converting it, but we are pretty much going from one to the other in units of 10. Everything's going in units of 10. Whether you're going from one way to the other way, you are always going in units of 10. Sometimes you are dividing, and sometimes you are multiplying. When you go in this direction, you are going to multiply by 10. And when you're going in the opposite direction, you divide by 10 each time. But we're not going to focus on this for this lesson. This lesson will just cover how you calculate the perimeter and area of 2D figures. All of these figures will be covered. We're first going to start with a rectangle, and I've already drawn for you a rectangle. It is very blank, but we're going to fill it out with some important symbols. There are things that we know about a rectangle. We know that what makes a rectangle is that these sides and these sides are the same length. So we denote them using these little lines or dashes. We also know that this is usually considered the length of the rectangle, whereas this is considered the width of the rectangle. And for the purpose of us calculating perimeter today and area, we are going to call this L, and we're going to just call this W, just to make it easier. There are other things that we know about this rectangle before we talk about its perimeter and area. We also know that each of these are 90-degree angles. They are perpendicular, so they create 90-degree angles. That also tells us that if we were to add up this angle plus this angle plus this angle plus this angle, all of the angles are 360 degrees, add up to 360 degrees. And the last thing that we need to know is that there's a very special place where, say, the lengths are in relation to each other. That is that this here line is parallel to this line too. So we give it one of these arrows. Now, the widths are also parallel to one another, but we want to make sure that they are not the same as the length. So we're going to put two little arrows to say that those match up. Now let's talk about the perimeter. In the first slide, we said that the perimeter was everything that was around the figure. So everything that's around added together. So of course, it could be as easy as doing length plus width plus width. And that's equal to the perimeter. Another way that you could calculate this is if you know that there's two lengths and two widths, you could just do 2 times the length plus 2 times the width. Both of these would work. it's whatever you prefer. When you are calculating the area, so the space that is inside, what is inside this shape, when you calculate area, it's a very simple calculation of just doing the length times the width. Keep in mind, however, that it's always units squared, centimeters squared, meters squared, it's always units squared. So that's it for the rectangle in terms of its perimeter and its area. Next, we're going to move on to the square, which is also a very important shape. I've already put that all of the sides are the same length with these little dashes or lines here. These are also 90-degree angles, and that these two lines are parallel, whereas these two lengths are parallel. You could also call this the length and this the width. But the thing about a square is that all the sides are the same. There's no difference between the length and the width and the width and the length. So for the purpose of this, we're just going to call this side, and we're going to denote it as a little s. When we're talking about the perimeter, since all the sides are the same length, you could literally do s plus s plus s plus s. Or you know that there's 4 s's, so you could just do 1s multiplied by 4 and give you 4s. In this case, the area is pretty much like a rectangle, especially because a square is actually a type of rectangle. In this case, you're not going to do length times width like you did for the rectangle. We're actually going to use the letter S, and we're going to do side times the side. That'll give you what's on the inside, right? That's the area is what's on the inside. But you could also change this in an exponential form. S times S is the same thing as S squared. Both would work. So those are your two options for area and your two options for perimeter when it comes to a square. Next, we're going to look at what a parallelogram is. This here is a parallelogram. It comes in many different shapes and sizes, but it will always be slanted in the way that you see it here. It sort of reminds you of a rectangle, except it has different rules. These sides here are parallel to each other, and these sides here are parallel to each other. This length is the same as this length, and the widths are also the same. The difference from this and a rectangle is that these angles are not equal to 90 degrees. However, they should still all add up to 360 degrees. You'll also notice that I added this line here, which we call the height. And the height is important because it creates a 90-degree angle from the top to the bottom of the parallelogram. Note that you could have drawn the height here, you could have drawn the height here, you could have drawn it anywhere. But for aesthetics purposes, I just decided to put it in this space instead. When we are talking about a parallelogram, because we have a height, we're actually not going to refer to this as length and width. We're actually going to refer to this piece here as the base with the letter B. But because it's the same as this line on the top, we're also going to call this line B. These sides here, we cannot call H. You could call them W, but for this case, I'm going to call them A and A. So now let's go down to the perimeter. Remember that the perimeter is around. So even though I have the height, you're not going to include it when you're calculating the perimeter. Instead, you're going to just do A plus B plus A plus B in whatever order you want, but adding them all together. Just like the rectangle, though, you'll notice that you have 2 A's and you have 2 B's. So you can always choose to calculate the perimeter in this way instead. For the area, it's not like length times width, but instead you're dealing with the base and the height, which we are going to call H. When we are calculating the area of a parallelogram, we always do whatever the base is times the height. And recall that the answer will always be in units squared. That's why it's important for you to know what this line is here, where it meets at a 90 degree, because it'll help you calculate the area. Similar to a parallelogram, we have a rhombus. A lot of people describe a rhombus as a type of diamond, which is okay, but it is known as a rhombus. A rhombus is similar to both the parallelogram and the square. All of its sides, as you notice here that I've put, are the same side length. But it looks like a parallelogram in that it is slanted, and that I have drawn this height here, which will help us calculate the area. I've drawn the exact same rhombus on the bottom, except instead of adding the height that I did for the first one, I have drawn 2 diagonals across. This I'll explain when we talk about area. When we're dealing with the rhombus, however, we are still going to use the letter S, because just like a square, all the sides are the same. So when we're talking about perimeter, we can just do S plus S plus S plus S, or 4S. And remember, we're not including the height. Yes, we're including all of the side lengths around. For the area, because I've drawn 2 different pictures, you could actually calculate the area in 2 different ways, depending on what you're given. Just to help us though, I'm going to label this like the parallelogram H for height. And here, I'm going to label the big diagonal with a big D and a small diagonal with a little d. I hope you know what I mean by diagonals. This is the small diagonal, this is the long diagonal. For the area of a rhombus using the height, it's just going to be S times H. So kind of like base times height, only our base is the letter S. If you are given this type of rhombus, you calculate it as D times D divided by 2. Once again, for either of these, it's always going to be in units squared. And the area is calculating all of what's on the inside of these rhombi. Next, we're going to talk about a trapezoid, or a trapezium. I have drawn 3 different trapezoids for you because I wanted to show you that there's one thing that makes a trapezoid. Well, one of the things is that there's 4 sides, but also both the top and the bottom need to be parallel. Here are 3 different types of trapezoids. This one is considered an isosceles trapezoid because these sides are the same. This one is considered a right trapezoid because it has a right angle already embedded in it. This one here we could call just a regular trapezoid where none of the sides are the same length and you have still the top and the bottom are parallel. For the sake of this lesson, you'll notice that both the top and the bottom are parallel. We can consider these bases. Because the bottom is a bigger base, we're going to denote it as big B, or capital B, and this one is going to be a small b. And I'm going to do that for all of our trapezoids. For the sake of this lesson as well, we are going to have to call the height h. And for the top and the bottom, we'll just be consistent, and this is A, and this is C, even though it's the same as A. We'll call this C, and we'll call this A and C. So if we're talking about the first trapezoid, and we'll maybe label these 1, 2, and 3. For the first trapezoid, to calculate the perimeter, you're just going to do, and you know what, because we're labeling it, I'm still going to call this A. We could do A plus B plus A plus big B. Or you could do 2 times A plus little b plus big B. For the second trapezoid, you can only really just do H plus B plus C plus B. And for the third one, A plus B plus C plus big B. So now I'm going to calculate the area of a trapezoid, and the area of a trapezoid, and once again, it's everything that's on the inside. So the area of a trapezoid is calculated using this formula. We say big base plus little base, and this is where order of operations come in handy. It's big base plus little base first, then you multiply that by the height, and you divide it by 2. And dividing it by 2 is done at the end. Another way that you might have seen it written would be something like half of whatever the big base plus little base times the height is. But just because I'm going to highlight as a reminder that you do this first, and you do this first. Then you multiply, then you divide by 2, or you just multiply by a half, or 0.5, if you will. So that's how to calculate the area and the perimeter of a trapezoid. Our next shape is a triangle. And just like we did for the trapezoid, I'm going to label it with you. I've given you 2 different types of triangles because I feel like those are the 2 types of triangles that you will see. And they are a little different and could be a bit difficult for some of us to actually label or recognize. So this is a right angle triangle, this first triangle, and we're going to label the sides A, B, and C. And for this small triangle here, we're also going to label it A, B, and C, but you'll notice that I have made this line in the middle with the right angle box, which means it's the height. Now, speaking of which, in the first one, you're also given a line with a box. So if I want to be consistent, I'm going to change this A here to H to show everybody that this side here is actually the height of the triangle. We didn't need to draw this line here for us to get it. It was already there. That's what's special about a right angle triangle. So for the perimeter, for something like triangle 1, you would just do H plus C plus B, right? You're going to do everything around. And for the second triangle down here, you would just do A plus B plus C. So what's interesting about the area of a triangle is that it's similar to the area of a parallelogram in that you would be basically taking your parallelogram, and I'm going to draw one really quickly here. If I were to cut this in half, I have made two triangles. And so it's not, in our case, going to just be base times height. It's going to be base times the height, but we're going to divide it by 2. So that's a triangle's perimeter and area. Last, we have a special shape, which we call the circle. In order for us to figure out the perimeter and area of the circle, we have to know 2 particular parts about the circle. I have another lesson on parts of a circle in case you're not familiar. Otherwise, I'll give you a very brief crash course. In this circle here, you have the center, which I've dotted as a purple, and I've drawn a line going from one side of the circle to the other side of the circle and through the center of the circle. We call this line here, this is the diameter of the circle. The other part of a circle that's really important in this case is what's called the radius. This is called the radius. What do you notice, though, between the first and the second picture? The radius in this case is actually half of the diameter. So we say that the radius is equal to the diameter divided by 2. Or you could say the radius times 2 is equal to the diameter. But they are interrelated. The radius, for the purpose of perimeter and area, is particularly important. The diameter can be used to calculate the perimeter, but it cannot be used to calculate the area. Now in this case, though, I do have the word perimeter with a blank. That's because for a circle, the perimeter of a circle is actually called the circumference. So we don't normally say find the perimeter of a circle, we say find the circumference of the circle. But we still mean that we are trying to find the measurement of what's around the circle. So for the perimeter of the circle, we are going to use the symbol or the number pi. Pi is a very interesting number because it's the only way for you to get pi is by doing the circumference divided by the diameter. You will always get the number pi. You can find on your calculator. Pi is also known as 3.14, but it also continues and goes on forever. But use the pi button on a calculator if that's necessary. The circumference could be pi d or pi times the diameter. And the other way of calculating it is 2 times pi times the radius, because 2 times the radius is the diameter. So it comes to the same thing whether you decide to use the radius or the diameter, and I hope that you know that I'm implying that there's multiplication between these. So you're going to have to multiply together, just in case you're not sure what all of these symbols mushed together mean. And then we have the area of a circle. The area of a circle is calculated by, again, using pi, but now multiplying it by the radius squared. So you're going to have to square the radius. Order of operations, though, if you're given that the radius, for example, the radius is 5 centimeters, to calculate the actual area, you would have to do pi times 5 squared. Some calculators, if you do it all at once, it's not the end of the world, but always remember that you need to do your exponents first before you multiply. And then 5 squared is 25. Just as a side note, and of course, our units are always going to be squared. In this lesson, you have officially covered all of the main perimeter and areas of shapes. We've covered the circle, the triangle, the trapezoid, the rhombus, the parallelogram, the square, and finally the rectangle.